Here's where we left off in chapter 9. The excavator had come in, dug down to immovable rocks, and that pretty much ended the day. The sonotubes there are just kind of in the holes to try them out, but no serious positioning had taken place. Then a week elapsed, and we're back now on a Saturday, and the boys are back to finish off the job. So what you see here is lots of measuring with the laser level, regular bubble level, tape measures, cutting sonotubes because the bottoms of the holes are extremely irregular, and lots of making sure everything is the way it's supposed to be. Cutting. And then the laser level again to make sure the top of the sonotube is where it needs to be. Stabilizing the sonotubes by backfilling with some of the dirt that was removed. More leveling here. And then, as I said in the previous video, immovable rocks are going to get drilled into with a hammer drill, and then rebar is going to be pounded in to the hole, and you're going to see that Isaac is going to switch now to a sledge and pound that rebar into the hole in the rock. And here's the rebar in the bottom of the sonotube, and when it gets filled in with concrete, the rebar will anchor the concrete in the sonotube to the rock. So work proceeded along those lines with all 9 of the piers, all the sonotubes positioned, leveled, and ready for the concrete pour. So this nifty machine pours the concrete. You just connect it to a water supply. You toss in the concrete mix, and the resulting mixture comes out the spout, and they just position it over each sonotube, and it proceeds very well. Then after each sonotube got filled and the top troweled off, Isaac set the bolts into the tube, and going to have to use some force to push them down into the concrete. I told him to leave at least 7 inches on top, go through the beam, which is 5.5 inches high, and as you'll see later, some of the bolts stuck way up in the air, but that doesn't matter. I'm going to cut them off anyway. Unfortunately, after about 7.5 piers, the super convenient mixer broke. They pulled the auger out, but apparently totally discombobulated. So the last bit they had to mix by hand in a bucket. They probably mixed, I don't know, at least a half a dozen batches. But they got all the sonotubes filled, they got all the bolts in, everything trailed off, and they finished, and then moved all the soil that that excavator had trenched out of there back into position. And they didn't finish till, I would say, about 9 o'clock at night, maybe even later, maybe 9:30. It was dark, and I noticed the next morning they left a few things around, but basically they finished the job. Here I am out the next morning to look over the job in the daylight. And yep, we got the piers there to the top of the sonotubes. It's supposed to be level. We're going to get to that. Each pier has a bolt, half-inch bolt sticking up so I can attach the beams. The bolts have a certain distance they're supposed to be, and we're going to see about that also. Here's the criteria I'm going to use to evaluate the quality of work on the piers. Are they level with one another? Are the corners at 90 degrees? Are the bolts spaced the way they're supposed to be? More importantly, are the piers located so the beams for a 10 by 12 shed be fully on the piers? And lastly, the direction. Does it point south as it's supposed to? Not having a laser level, what I did is just put a string line with a bubble level hooked onto it between the bolts, and then I wrapped that all the way around the perimeter, and I had to go around and adjust the string line up and down, moving the level from place to place until I got it pretty much right. And then I just put a ruler on it and measured the distance from the concrete to the string line. So I recorded each of the 9 numbers and put them on this diagram. Those are the numbers that are in italics and purple. So for example, 15 centimeters for the northwest corner at upper left in the diagram, and then 16.2 for the middle of the north, and 16 for the northeast corner, and so on all the way around. So, it varies from about 16.2 centimeters from the string line to the concrete down to 12.2 from the string line to the concrete. So that's a variation of 4 centimeters. Now, some of it is because my string line is not perfectly level. Some of it is because the piers aren't perfectly level. The concrete is kind of rough, so when I put the ruler down, where is it exactly? But anyway, this is roughly what we're dealing with. The piers are not completely level, and when I put the beams on there, I'm probably going to have to shim the beams to get them to be level. Also, the beams have a lot of variation, so all that put together, and it'll be quite an operation when it comes time to put the beams on to get them all adjusted. But of course, the concrete's not going to move, so that's a given. Next, I used a tape measure to measure the distance between the bolts just about every possible way. So for example, the bolt at the northwest corner to the bolt in the middle of the north wall is 171.8 centimeters. And then from that middle to the northeast corner is 171, and so on. So I wrote all those numbers down and then came back to the computer and typed them all into the diagram. And I'll show you what I'm going to do with those numbers. So pay particular attention to what's going on the west side. The pier in the middle of the west wall to the pier at the southwest is only 115 and a half centimeters. It's way off compared to, for example, the northwest, the middle of the west, which is 145.8. So that southwest pier is too far to the north. And then if you look at all the text, 9.71 feet was specified between the bolt at the northwest and the southwest, and it turned out to be only 8.67. So it was actually a foot off. On the east side, not so bad, just a little off. And so this is going to create a problem which I'm going to show you as this video proceeds. Now, with all those lengths recorded, all of the straight segments around the perimeter and all the angles between bolts, it's possible to calculate the angle of the corners as poured. I mean, they're supposed to be 90 degrees, but we want to know what they actually are using trigonometry. And what we use is called the law of cosines. I'm not sure where that name came from, but anyway, the formulas at the top here. If you have two sides, not necessarily at 90 degrees, call them B and C, and then another side, A. This is the formula here, this formula there. B squared plus C squared minus A squared divided by 2 times B times C. You take the inverse cosine or the arc cosine of that, gives you the angle. The tape measure has a ring on it. I'll show you a picture of that in a few seconds here. And consequently, the number that I read off of the tape measure has to be increased by 1.64 millimeters, 1.64 centimeters to account for the ring that goes around the bolt. Here's the clip I added to help me hold the tape measure to the bolt, and it moves the tape measure 1.64 centimeters away from the center of the bolt. So where it says A raw, B raw, and C raw, those are the actual numbers off the tape measure, and A, B, and C here, which is what we're going to use in the calculation, are those numbers increased by 1.64 centimeters. So for the first corner, which is the northwest corner, we have sides of 226.9 centimeters, 171.8 centimeters, 145.8 centimeters, and then we increase those numbers because of the ring, and then we can take B, was it A squared, B squared, and C squared, calculate B squared plus C squared minus A squared, calculate 2BC, and then do this. This is the argument to the arc cosine, and this is the arc cosine result in radians, and that has to be converted to degrees. So using the actual numbers off of the pour in that northwest corner comes up to 90.46 degrees. Not bad. And then the southwest corner, similar idea using the numbers that I measured here, and we get 92.94, a little farther off. The southeast corner comes out to 85.33. It's kind of off. Northeast corner, 91.56, a little bit off. And the last column is just to demonstrate that this whole thing makes sense. So if you take an A of 5, a B of 3, and a C of 4, that's the 3, 4, 5 triangle, and you do the whole thing, and it comes out to be 90. You see, so this actually works. So what do these angles mean? It doesn't mean that the greenhouse is going to be off by 3 degrees in the southwest corner and almost 5 degrees in the southeast corner. It doesn't mean that. What it means is that when I put the beams down on top of the piers, I can't go by the bolts. I need to put the beams down at 90 degrees, which I can easily do by jockeying the beams. And then when I bolt them, I'll bolt them into the position they need to be in. In the end, it doesn't make any difference where the bolts are. It doesn't really make any difference if they're 90 degrees, as long as they're not so far off that they can't go through the beam. Whether that happens or not, I don't actually know. The beams aren't straight anyway. Um, and we'll face that when we come to it. Uh, well, this whole discussion here, this is just the point here is that the drawing no longer matters. That's the specification I gave to Isaac. What matters is the concrete as poured and the bolts as they are, and that's what we have to deal with. Or to say it another way, whatever's out there is set in stone, isn't it? Now for what is surely the most important thing, which is will the beam sit fully on the piers? And so I took the frame, which is a very accurate and very square 10 by 12 that we used originally to find the location for the greenhouse, and I set that on top of the piers. And you can even see from this photo that the beam will not sit fully on the piers. These 2x4s are flat side horizontal, so they're the same width as the beam will be. The beam is a 4x6. These are, call it a 4x2. And you can see in that problematical southwest corner that the two beams, the one going north-south, one going east-west, barely fit on the pier. And this is after a lot of jockeying around with this frame to come up with the only position that would get all of the beams at least partially on concrete. And so this is going to be a problem, and I will show you with some close-ups here how I'm going to deal with it. Here's what the southwest corner is going to look like, and you see those beams just catch a piece of the pier. So I'm going to sister them. A sister to a joist or a beam or even a stud is another piece of similar wood that is bolted or screwed to it to double up its width. Now, in this case, there'll be two sisters, one for the east-west and one for the north-south. There'll be, uh, these are just little blocks. The sisters will be much longer. In fact, they might even be the full length. I'm not quite sure about that yet. But anyway, they'll also be 4x6s. They'll be bolted using several bolts to the main beam, and the one bolted to the east-west, that is the 12-foot southern beam that supports the south wall, um, will be fully on the pier, and the one bolted to the west wall will also be fully on the pier, and it will be the one that the bolt goes through. So the bolt is not going to go through the primary north-south beam. It's going to totally miss the beam, but that's okay because it'll get the beam sister. Now here's the middle of the south wall. The beam not only barely catches the pier, so it needs a sister, but that sister, being 4 inches wide, won't reach the um, won't reach the bolt. So I guess we'll call those twin sisters, and that inner sister will meet the bolt. Now here's the northeast corner. The east-west beam that constitutes the north wall goes right through the bolt, and so it's on the pier, and that's good. But the eastern beam is it doesn't quite catch. It catches only part of the pier, and it needs a sister, which it will get. And it looks like the sister might just go right up to the bolt. The sister is probably sufficiently on the pier. And finally, the only other corner where a beam is not fully on the pier is the northwest corner. One of the beams goes through the bolt, which is nice. The other one um, catches only part of the pier, and so it needs and will get a sister. As for the piers that are not at the corners, other than the one I already talked about, which was the middle of the south wall, the beams are fully on the piers. That is the middle of the west wall, the middle of the east wall, the middle of the north wall. That part's okay. All three of them, however, miss the bolt, and we'll need a sister not to help them stay on the pier, but to have something to bolt to. Um, so anyway, I have figured out something that works, an arrangement of this frame that comes as close as possible, and then um, a method of using sisters to tie everything down. I'm going to take this frame apart and then use it as a template to drill into the beams so the beams can come down onto the bolts. Fortunately, but sadly, um, the beams have either one or zero bolt holes mostly, and ironically, that makes it easier to position the beam on the piers. It's the sisters mostly that are getting the bolt holes. Anyway, this will all be worked out, and there'll be a video to show you how this goes down. In the end, um, after all of my horsing around, the beams will be well supported with their sisters, and everything will be bolted down. Everything will be square. It will indeed be 10 by 12. To make it smaller at this point would be cheating. We're not going to do that. It's going to be 10 by 12. And finally, the direction. The string is lined up along the north-south axis, taking a pair of bolts, but I actually tried a few pairs. The compass is oriented towards magnetic north, and so the south wall is in fact somewhat southeast. Some people think the greenhouse should be southeast to pick up the morning light. Others say south, others say south-southeast. Um, but the reality is the greenhouse has windows all around. The direction probably is not very critical, but I think we're very nicely placed a little bit to the southeast. So here's where we are. Uh, these are the piers. And what I need to do over the next couple of days is set up shop here. I need to move all of the wood that's still sitting in the driveway, including the beams, over to here. I need to move my miter saw over to here. I need to start work on the beams, drilling the holes, fashioning the sisters, bolting the sisters, getting all that set up.